Next, for the perpendicular bisector, there's also inequality. It's either more than or less than. It depends on the question. So now, let's say we want to sketch this. So as usual, you have to figure out what's the point A and the point B. Right, so for this point, it should be a 0, 2. As for this point, it should be a 4, 0. Alright, so let's sketch over here. 1, 2, 3, 4, 4, 0. The other point is 0, 2. So connect these 2 points by using dotted line. And then roughly at the midpoint here, you draw a perpendicular bisector. Okay, so by drawing this line, it represents the equal sign, the equation of a perpendicular bisector. But look at this inequality carefully. Now it's more than, and there's no equal sign here. So it's the same as a circle. When there's no equal sign, the line here becomes a dotted line, because if without the equal sign, that means the line is not included, so it must be in dotted line. Alright, so since it's an inequality, which means we have to either shade the left hand side or the right hand side. Okay, so what to do is, I will suggest you to put a Z at the left hand side and a Z at the right hand side. So this Z point here, you can put at any place at the left hand side or any place at the right hand side. Then what to do with this Z? According to the inequality here, they want the distance between Z and the point 2i more than the distance between Z and the point 4. So let's check. If our Z is over here, and the distance between Z and 2 and the distance between Z and 4, now we compare these two distances. Which one is longer? Z and 4 is longer, isn't it? But according to the question, they want Z and 2 to be more than the distance between Z and 4, which means the Z shouldn't be here. Now have a look at this Z over here. Now you measure for the distance between Z and 4, distance between Z and 2. Then you try to compare. Distance between Z and 2 is longer, which fulfill this inequality, because they want distance between Z and 2 to be more than the distance between Z and 4. So this Z is the right one. So this one is just a guideline for you to know where the Z is located. So now we know that the locus should be over this side. Then we can shade this side. As simple as this. Alright, so one more example at the bottom here. Figure out the points. So here, modulo Z means Z minus 0. It means the origin 0, 0. As a point here, it should be 1, 0. Okay. So a point at the origin, a point at 1, 0. And draw a perpendicular bisector. And for this perpendicular bisector, it should be a solid line because there's an equal sign over here. Okay, and now notice that it's more than. So whether to put the locus at the left hand side here or the right hand side here, you can use the same method. Put a Z here and a Z here. Okay, according to the question, they want the distance between Z and origin to be more than the distance between Z and 1. So let's say my Z is over here, distance between Z and origin compared to distance between Z and 1. So Z and 1 is longer, but according to the question, they want Z and origin to be longer, which means the Z is not supposed to be here. So check for the Z over here. So compare the distance between Z and 1, Z and origin. Z and origin is longer, which is what is requested by the question. So the Z should be at the right hand side, and hence we shade the right hand side. This is about the perpendicular bisectors inequality. Alright. So now comes to the third one, the loci involving argument. So have a look at the general formula here. Argument, bracket z minus a equals to alpha. So this one means it represents a line that produced from the point A, which is referring to this point A, towards the direction of the angle alpha. So this alpha is actually the angle from the horizontal. Okay, so same thing here, you got to recognize this equation and make sure that this symbol is a minus and not a plus. Have a look at the diagram at the right hand side here. So how to sketch this locus that involve the argument is very simple. You just need to recognize the point A. Let's say it's a fixed point here, point A, and then from the point A you draw a reference line that is parallel to the x-axis, and from this line you make alpha angle. So if you are not sure about the angle, then maybe you can measure by using the protractor, and from here, let's say it's 30 degrees, then from this point you just draw a line. So this line will represent the locus. It's just a straight line. Alright, so let's look at the example here. For the A, you got to make sure that it's a minus here, and the point, we start from the point 1, 0. Okay, so let's sketch for the A. We start from the point 1, 0 here and make pi over 4. Pi over 4 means it's about 45 degrees. So just label here pi over 4. So this line here will be the locus that is requested by this equation. Have a look at the B. For the B, you have to figure out that this point here is 2 and 1. Okay, so same thing, prepare the Argand diagram, plot the 2 and the 1, and from this point you have to make pi over 6 angle, which is about 30 degrees. That's how we sketch the locus of the argument line. What about the C? The C's point, it should be 1 and -2. So from the point 1 and -2, somewhere here, then you draw a line that is parallel to the x-axis as a reference line to calculate for the angle, and notice that this angle is negative pi over 4, which is negative 45 degrees. If it is negative, that means we have to draw the line in negative direction, which is here. Okay, that's how we sketch the argument straight line. And of course, there's argument inequality, but the method is the same. So let's say for the A, figure out that the point here is, since it's z, means it's z minus 0. So it's from the origin. So from the origin, you make 3 pi over 4 to pi. 3 pi over 4 is about 135 degrees from the origin until pi. Pi is 180 degrees. So take note here, it's the same as the perpendicular bisector and the circle. If there's equal sign here, that means the two lines here are included and it should be a solid line. So they want in between. That means they want more than 135 degrees but less than or equals to 180 degrees. That means it's here. So you shade in between. But remember to label the angle. Okay, that's argument lines inequality. So have a look at the second one here. The point here is a 1, 0. So 1, 0 is somewhere here, and the angle in between pi over 3 to 2 pi over 3. So pi over 3 is about 60 degree. 2 pi over 3 is about 120 degree. So now they want more than 60 but less than 120. So it should be in between, right? But take note, for this one there's no equal sign, and for this one there's an equal sign. That means for 2 pi over 3 here, the 2 pi over 3 line, it should be a solid line. A solid line here, 2 pi over 3. As for the pi over 3 here, it should be dotted line. And then only use shade in between. Okay, that's all for the locus. So for the locus, there are 3 different types. The first one is circle, second one is perpendicular bisector, and the third one is argument straight line. Let's try to apply what we have just learned into these past year questions. So have a look here at the May June 2020 variance 33 question. Have a look at the part B. Part B, on a sketch of an Argand diagram, shade the region whose points represent the complex numbers that satisfy all these inequalities. So notice here that there are 3 inequalities, and we have to sketch all these 3 in the same diagram. So you just need to prepare one Argand diagram. Label the imaginary axis and the real axis. So have a look at the first one here. One side is modulus, the other side is a constant, which means it's a circle. And for this circle, the radius is a 2, and the center here, it should be 2, 2. So 1, 2, 1, 2. Center over here, radius 2. So make sure that your circle is touching the x and y axis. Okay, so this is our circle, and it's less than or equals to 2. That means you have to shade inside the circle, and the circle must be a solid line. So before we shade it, we got to consider other inequalities as well, because you are asked to shade the points that represents all 3 inequalities, which is the intersection point. Alright, have a look at the second one. It's argument straight line that start from the origin. Alright, so we start from the origin here, and then we make the angle from 0 to pi over 4, which means it's from 0 to 45 degree. So 0 is over here, and notice that the 45 degree will pass through the center of the circle, because the center of the circle coordinate is 2, 2. Okay, so there's a line here, and there's a line over here as well. So in between, that means it's here. But let's not shade it first, because we have to consider for the third one. Okay, what is the third one? Real z less than or equals to 3. The real z here means the real axis. So what is the real axis in Argand diagram? It's actually x-axis. If I write it in this form, x less than or equal to 3, is it easier to recognize it? So x equals to 3, it should be here. The straight line here, x equals to 3. It's a vertical line. Less than 3 means here. So now, for these 3 inequalities, the intersection part is less than, that means it's inside the circle. And then this one means in between, here to here. This one means less than 3. So intersection part should be here. Alright, you just need to shade the intersection part, then you can easily get the 5 marks. Let's try one more question here. Have a look at the May-June 2019 paper, variance 33. Have a look at the part 3 here. So So same type of question on a sketch of an Argand diagram. Shade the region that represents these two inequalities. Okay, so have a look here. For the first one side modulus, one side radius. So it's a circle. As for the second one, both sides are having the modulus. So it should be a perpendicular bisector. So let's prepare the imaginary axis and the real axis first. Let's sketch for the first one. It's a circle where the center here, it should be 0, 0 with the radius 2. Okay, so the radius 2, that means intersect here at 2 and -2. And take note here, there's no equal sign here for this inequality, which means the circle should be in dotted line. And less than 2 means you have to shade the area inside the circle. But before we can shade it, we got to consider the second inequality as well. So for this perpendicular bisector, the point here is the point U. So point U actually we have found out in the part 1 here. So let's make use of the answer at the bottom here. Negative square root 3 plus I. So that means the point here is negative square root 3 and 1. 1 for the I. As for the other point here, is z minus 0. So it's 0, 0 at the origin. So one point is at the origin. The other point is at negative root 3 and 1. So it's somewhere here. So for the perpendicular bisector, you just need to connect the 2 points by using a dotted line as a reference line and then draw a straight line, perpendicular bisector. Take note that for this perpendicular bisector, the inequality sign here, there's no equal sign as well, which means for this line, it should be dotted line as well. Then either we need to shade the left hand side or the right hand side. Then we have to check. So they want the distance between Z and U less than the distance between Z and the origin. So okay, I'll label here as a U. Then I put a Z here at the left hand side and the Z at the right hand side. Then you check for the distance. So distance between Z and U compared to the distance between Z and the origin. So Z and the origin is longer, which is what is requested by the inequality here. So the Z should be at the left hand side. But let's double confirm it. If my Z is at the right hand side, distance between Z and U compared to distance between Z and origin is shorter, which is incorrect. So that means we should shade the left hand side. So now you can just erase off the Z and shade the intersection part, left hand side, and in the circle means it's over here. And yep, you can get the 4 marks easily. So that's all for the lesson today, which is about the 3 different types of locus in the complex numbers Argand diagram. Thanks for watching and see you in the next video.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.